Hello everyone, we're looking at question number 1 of winter 2018 paper 2-1 5054. The question reads, a girl of mass 35 kg on a bicycle accelerates from rest and travels down a slope in a straight line. The girl does not use the pedals. Figure 1.1 shows that the gradient of the slope is constant. Calculate the resultant force when she is accelerating at 2.6. Pretty straightforward. When they want you to find the resultant force, that is denoted by capital F, and they have the acceleration, we have the mass as well. So all of these things, they come in this formula, F equals ma, where this F is the resultant force which we have to find. Mass is given to us as 35 into acceleration, which is given to us as 2.6, and when you multiply these you get 91 newtons, and you have to write down the unit as well because they haven't written it themselves. Moving on towards B part, that says at first her acceleration is constant. At time t1 her acceleration starts to decrease gradually until she is traveling at a constant speed in a straight line. On figure 1.2, sketch a speed time graph for the girl from when she starts moving until she's traveling at a constant speed. Now, I've said this so many times, whenever you're given a graph, you have to look at its axis and try to see if its gradient or area under the graph could give you something. Now, we have speed here and we have time here, and if the gradient speed over time, that rings a bell, that is accelerations, because acceleration is a rate of change of velocity. When we say acceleration is essentially change in velocity over time. So this is acceleration. Now I know that its gradient is going to give me acceleration, and whenever you are plotting a graph, it's best to read the question step by step. Starting off with the first line, that says at first her acceleration is constant. Stop here, plot this, and then you move forward. Her acceleration is constant. When we say acceleration is constant, speed time graph gradient has to show that acceleration is constant. And how do I show that? I need to show that by showing a constant gradient. Now how does my constant gradient looks like? And at time t1, so it has to go till time t1, so constant gradient has to look like this. Now most of the students might argue that why can't the graph go like why can't the graph go straight like this? The reason being, because if for example I have 20 speed here, this shows that the speed remains constant, and whenever you have a horizontal line, always remember the gradient of a horizontal line is 0, not constant. So we do not need a 0 gradient, we need a constant gradient, and that constant gradient is always like this. So we have this blue line right here. Then you have the second part that says at time t1 her acceleration starts to decrease gradually. Let's pause here. Acceleration starts to decrease gradually. That means we have to show a decreasing gradient. How do we show a decreasing gradient? It has to look like this. A decreasing gradient, it has to be a smooth line, and then until she is traveling at a constant speed. Now this said constant acceleration, this says constant speed. There is a difference. When we say constant speed, that is when you have to form that straight horizontal line, because if for example I have, let's say, 8 here, and I just make a straight horizontal line here, this means that the speed throughout this time remained 8, it remained constant. However, whenever you have a constant speed, your acceleration is 0. Why? Because acceleration is change in velocity. So if you're not having a change in velocity, you do not have an acceleration. So if I have a constant speed, I have to make sure that I take this straight, I continue this with a straight line like this. So it was acceleration was constant. You have to read the question very carefully. Acceleration was constant, that means constant gradient. Then it started decreasing gradually, and then it is constant speed, which means zero acceleration. This is it for B part. Moving on towards C, second part, that says state how the distance traveled is found from a speed time graph. Whenever you have distance, it's always the area under, not this area, so it's always this area. So we have to write the area under the graph the area under the graph gives us the distance. And this is it for the second part, and this is it for question number 1 as well.